In this next video in section 13.5, we're going to look at problem number 2 on the worksheet, which is asking us to do the same thing that we did for problem number 1, but just for a different function. So for part A, okay, we are going to just substitute in these expressions for x and y into our function for z, and here z is the natural log of x squared plus y squared. So that's going to give us z is equal to the natural log of x squared. So that's going to be 1 over t squared plus y squared, which would just give us a t. Okay, so now since z depends only on the single variable t, we can just take the ordinary Calc 1 derivative. dz dt would be 1 over what's inside, and then I'm going to multiply by the derivative of what's inside. Now the derivative of 1 over t squared, well, that's going to be what? Negative 2 over t cubed, right? Because 1 over t squared is t to the negative second power, and then I'm going to add to that 1 from the derivative of t. Okay, great. Let's clean this up a little bit. First, I'll just take this this expression here on the right and just put it up in the numerator. So I'm going to get negative 2 over t cubed plus 1, and then we're dividing all of that by 1 over t squared plus t. Okay, and now for this, I'm going to go ahead and clear out these denominators, okay, and I have a t cubed on top and a t squared, so let's go ahead and use the highest exponent term. So in other words, I'll multiply the top by t cubed as well as the bottom, and then we can go ahead and distribute this t cubed here and here, and then down here it'll distribute as well. So that's going to bring us to what? It's going to bring us to a negative 2 plus a t cubed divided by, so t cubed over t squared, so that'd just be a t plus t times t cubed would be t to the 4th. Okay, great. And I'm going to go ahead and factor out a t from the denominator, and then also I'm going to rearrange the numerator. So I get t cubed minus 2 all divided by t times the quantity of maybe t cubed plus 1. Okay, cool. So this would be our answer, just taking the Calc 1 approach, right? So now let's go ahead and apply the multivariable chain rule. Okay, so here's our diagram for the chain rule, and we can say that dz dt is equal to, well, the change of z with respect to t in the x direction, which is just the product of these blue rates. So del z del x times dx dt, and then we're going to add to that the product of the green rates, the change of z with respect to t in the y direction. So we get that. So then what are we going to get here? Well, del z del x. In terms of x and y, right, z is the natural log of x squared plus y squared. So differentiating this, I'm going to get 1 over what's inside times the derivative of what's inside with respect to x, and that's going to give me a 2x. Okay, so that would be del z del x, and then multiply that by dx dt. Well, x is t to the negative first power, right? It's 1 over t, so that's going to be negative 1 over t squared then for the derivative. Okay, so this again is the product of those rates in blue. Okay, pretty nice. Moving on, then we're going to get del z del y, and that's going to look just like del z del x, except we're just swapping out the roles of x and y because of the symmetry. And then we're going to multiply by the derivative of y, and that's going to be what? Well, y is t to the 1/2 power, so differentiating we'll get a half times t to the negative 1/2, or put another way, 1 over 2 times the square root of t. Okay, good. So these are the product of the green rates. Alright, so now our job is to rewrite all of this in terms of just t to show that it is in fact equal to what we got in part A, and then just to do some cleaning up here. Okay, so let's start with blue, right? I'm going to put the negative with the 2x, and I'm going to replace x with 1 over t. So I'm going to get minus 2 times 1 over t, and then I'm dividing that by x squared plus y squared, so that'd be 1 over t squared plus, and then squaring y is just going to give us t, and then I'm leaving the 1 over t squared out in front still. Okay, cool. Now for the second part, notice I can divide out these factors of 2. Okay, and I'm going to go ahead and replace y with the square root of t. So I'm going to get the square root of t over this same denominator, which is 1 over t squared plus t. And then I'm multiplying that by the 1 over the square root of t. Oh, and that's nice, because now I can go ahead and cancel out these square roots. Okay, so I'm getting there. What should I do next algebraically? Right, I'm trying to make this still, it's a mess, but you know, as simple as possible. The thing that really stands out to me looking at this is that I see that this expression shows up here and here. Okay, and so I do have a common denominator, so it might be tempting to distribute this t squared in here, but see, if I want to combine it with this, then I'm going to have to get a common denominator and blah blah blah, and I already kind of have that common denominator with this expression in red. So here's what I'm going to do. I'm actually going to go ahead and take this 1 over t squared, I'm going to throw it upstairs. Okay, because what that is going to do, it's going to give me this. I'm going to get a negative 2, and then the 1 over t and the 1 over t squared will multiply. So I'll get minus 2 over t cubed over this common denominator. And then here I have just 1 over that common denominator. And now I can go ahead and just combine those. So you get 1 over t squared plus t. Okay, so now, right, I'm in a position to go ahead and clean this up, and I'll do that in really just the same way we did before. I'm going to multiply by t to the highest exponent, which would be t cubed here. And so that's going to give us what? It's going to give us distributing. This is really just like what we saw before, negative 2 plus t cubed divided by, distributing here, I'm going to get just a t plus a t to the 4th, right? And so then very, very lastly, right, I'll go ahead and continue over here. We're going to get what? T cubed minus 2 over t times t cubed plus 1. Same thing as before. Okay, cool. Well, they agree. I would argue this is definitely probably harder in this instance, but they do agree, and that's a good thing. All right, cool. I will see you in the next video.